Okay, so now that we've had our introduction to decimals here, and a little bit of converting between decimals and fractions, let's go ahead and look at our operations with decimals. Now, just a review of addition and subtraction. When we add or subtract, first of all, we need the same name. If they do not have the same name, we cannot add or subtract them. For whole numbers, that means line up the columns. Slash place values. You can only combine place values, the digits with the same place value. For fractions, what did that mean?
Same thing.
You had to have the common denominator, right? Second, once you had the same name, you combine the counts with whatever operation you're doing, and you also, and you keep the same name. So let's take a look at what this all means for our decimals. If I am going to add 0.21 and 0.3, of course I'm going to set them up vertically. If I try to add them like that, is that going to work?
No.
No. What is wrong with what I did there? You have to line up the decimal point. Why do we have to line up the decimal point? Fourth grade teacher told me to.
No, because adding 0 to 2 and 3 to 1 would not
Okay.
be close.
This is 21 hundredths, right? This is 3/10. They don't have the same name. We cannot combine them. So technically what we're doing, I got the right color here. There we go. That'll work. Is we're putting a 0 there to make that 30 hundredths. And now they do have the same name. And now the decimal points would naturally line up. Just like with whole numbers, where we had to line up the place values, we could only combine digits that had the same place value. Same thing here. I can only add the tenths to the other tenths and the hundredths to the other hundredths. So lining up the decimal points is a way of lining up those place values. So now when I add these digits, I'm going to start at the right and work my way back to the left, just like I did with whole numbers and integers. 1 plus 0 is 1. 2 plus 3 is 5. The decimal point comes straight down. Why does the decimal point come straight down? We keep the same name. By bringing that decimal point down, the tenths stay in the tenths column, in the tenth spot, and so on. We keep the same name. So in a problem like this one here, 0.583 plus 0.89, again, we do have to line up the decimal point. And technically, we should fill in any of those missing decimal places over here so that they're all lined up. And we are adding. So 3 plus 0 is
3.
3. 8 plus 9.
17.
Se-
1.
So we keep the 7 and carry the 1. 1 and 5 is 6. Plus 18 is
14.
so we
Drop the 4 and carry the 1.
we keep the 4 and we carry the 1. Now the 1 is over there with zeros. That's just going to be a 1. But before I do that, I have to
Bring down the decimal point.
bring down the decimal point. I don't want to cross that decimal point without bringing it down. So 1, 0, and 0 is just 1. So you'll notice here the decimal point did not affect our carrying. It did not affect our adding at all. All that we had to do, all the decimal point did was it told us where to line it up, and then we had to bring it straight down as we went through it. Any questions on adding the decimals? Subtracting is pretty much the same way. 0.73 minus 0.492. We have to make sure we line up the decimal point so that we have our tenths lined up with tenths and hundredths lined up with hundredths. Now here, what am I going to have to do? I'm going to have to fill in the missing place value first there. And then when I go to subtract, it's not carry, but it's borrow. There we go. Just like with whole numbers, we do start on the right and work our way back to the left. 0 minus 2 can't be done. So just like whole numbers, we're going to borrow from the 3. That becomes 2, and this becomes a 10. 10 minus 2? 8. 2 minus 9. Can't do it, so this becomes a 6, and this is a 12. 12 minus 9 is 3. 6 minus 4? 2. And my decimal point. So we might have 17.84 minus 9.873. Now, usually what I do for the second number is I put the decimal point in first so that it's lined up. Then I'm going to write the whole number part backwards. Well, there's only a 9 there, so I'll just put the 9 in front of the decimal point. Then I write the 873 afterwards. What do I have to put in here? The 0 in that missing place, in the thousandths place in the top number. So now what? Okay, 0 minus 3 can't be done, so we do have to borrow. So this becomes 3 and 10. 10 minus 3? 7. 3 minus 7? So borrow from the 8. That's a 7, and this is 13. 13 minus 7? 6. 7 minus 8? Can't be done. We borrow from the 7. This is a 6 and a 17. 17 minus 8? 9. Bring down the decimal point first, right? And then, yes, we're going to borrow from the 1. That's a 0, and this is a 16. 16 minus 9 is 7. So again, you see the borrowing, even we can borrow right through the decimal point. Decimal point does not affect our subtracting or our borrowing. All it does is show us where to line it up, and then we have to bring it straight down to keep it in the same spot. How about this one? What am I going to do there?
You're going to put a decimal point after the 8.
Good. The 8, even though there's no decimal point written there, it's implied to be at the end of the number. So it's 8 with the decimal point there. So that's where I line it up with the second number. Then what do I have to do? Fill in the zeros, and there will be 4 of them. So now I go to subtract. I'm going to start on the right and work my way back to the left again. 0 minus 5. Can't be done. So I'm going to borrow, but I look here and there's nothing to borrow there, is there? I can't just pretend it's a 10. I have to go until I find something to borrow from. Well, there's nothing here. I have to go all the way to the 8. So that becomes a 7. What that does is it makes this a 10. But I need to get it all the way down here, so I have to keep borrowing. So I borrow there, that's a 9, and this is a 10. Borrow again, that's a 9, and this is a 10. And I borrow again, that's a 9, and this is a 10. Now, some of you may have been taught a shortcut. You just borrow here and just go 9, 9, 9, 9, 10 on the last digit. Yeah. What's that?
I went to private school and I learned completely different than any of that.
How'd you learn it?
Okay, 5. Let's see, I'll just come up here, it's easier.
Okay.
Okay, so 5 from 0, you just pretend that's a 10, so 5 from 10 is 5, and then you add 1 to the 3 is 4 from 10 is 6, 1 to 8 is 9 from 10 is 1.
Oh.
And then you add the 1 to the 8 from 10 is 2, and then the 2 becomes a 3 from the 8 is a 5.
You know, that's the way. I have not seen that in a long time.
That's how I was taught,
Yep.
and I can just zip right through. See, this is super easy to me, but then when you get to all that other stuff, I'm over here in tears.
Sure.
Not the only one.
I didn't learn subtraction this way.
So you get the 5.2165. But yes, what you're saying is what you're doing. I had almost forgotten that method. I hadn't seen that in a long time.
Almost 46, and I went to a private school from kindergarten to 8th grade, and that's how they taught us. And I can do numbers in my head.
Oh, sure.
Nothing.
So yeah, you make this a 4, a 9, an 8, and a 3. You increase each of those by 1. Then you pretend these are 10s. And that's an 8.
I don't even write it down, I just do it in my head.
Yep. So yeah, 10 minus 5 is 5, 10 minus 4 is 6, 10 minus 9 is 1, 10 minus 8 is 2, which is exactly what we got there. 8 minus 3 is 5. Now the reason that works is because you are going to borrow from that, and that'll become a 7. This will be a 10, but then you're going to borrow from that to reduce it to a 9. So really, you're not increasing this by 1, you're reducing the 10 to a 9, but it's the same thing, right? Yeah. And actually, and that's it. Most of the people that I've seen that have been taught this method have been taught to do it backwards. They don't even write in the zeros. It's just you do, okay, 8 minus 3 is 5, 10 minus 8 is 2, 10 minus 9 is 1, 10 minus 4 is 6, and 10 minus 5 is 5. The last digit you don't add 1 to. That might be the next step to making it shorter, but yeah. And that's one of the things I do when I'm doing them in my head, is I do that process. I haven't actually written it out like this in a long time. Neat. Okay. So our next step. Multiplying and dividing. Remember, when we multiply or divide, we do not need the same name. What that means is when we're multiplying with whole numbers, we don't really worry about lining up the columns. I know we do anyway just to keep it neat, but when we're dealing with fractions, that means no need for a common denominator. Don't have to worry about common denominator. The second part of multiplication and division is we're going to combine the counts with whatever operation we're using. But instead of keeping the same name, when we multiply or divide, we also combine the name. So with decimals, what that looks like, let's say I have 0.21 times 0.3. When I write that out, I do not have to worry about lining up my decimal points. Remember, lining up the decimal points was the equivalent to making sure they had the same name. When we multiply or divide, we don't need to have the same name. So we don't need to line up the decimal points. So now we're going to multiply. We're going to combine the counts. 21 times 3, well, I'm going to do it out the long way. 3 times 1 is 3. 3 times 2 is 6. 21 times 3 is 63. Where does my decimal point go? We go 1, 2, 3 spots. We've got to add a 0 there and then put in our decimal point. Right? Why?
3 decimal places up above.
Yeah, we've been taught you have to count 1, 2, 3 decimal places in the problem. So you start at the end of your answer and count back 1, 2, 3 decimal places in the answer. Why?
Combining the counts.
The 4th grade teacher said so, darn it. Yeah. Well, you're right. We do combine the names, the 21 times, or the counts, I should say. The counts, 21 times 3 is 63. That's combining the counts. But this is hundredths. And this is tenths. And we also combine the names. Hundredths times tenths is thousandths. So counting those decimal places is nothing more than combining the names. Now, I'm going to look at division next. Notice I didn't waste a lot of time on multiplication because I realize you're going to punch it in the calculator. So we're going to come back here in a few minutes and we're going to look at estimation with decimals and how we would look at it. But let's do quick division. Now, if you remember way back on the first day of class, I showed you a method of long division that had some of you wondering whether you were going to stick around in the class. That looked way different than what we have seen for long division before. Remember, division is nothing more than an organized way of doing repeated subtraction. That's all it is. So if I wanted to divide 48.739 divided by 3.2. I really could just do 48.739 divided by 3.2 and go through my place values. This is the tenths place, or the tens place, right? 10 times 3.2 is 32. Can I subtract that? Yeah, I can subtract 32. I can subtract it once, right? And that's what I really did is subtracted 3.2 10 times, right? And I can go through that process. But that process is different than what we've seen. And I don't want to confuse you by showing you that whole process again. So what we're going to do is we're going to do it the conventional way. How do we divide by a decimal? Yeah, the correct answer is we don't, right? We see there's a decimal place here and the number we're dividing by. We get rid of it. We move it over. If we move this over 1 decimal place, what do we have to do in here? Move that one decimal place. So this becomes 487.39 divided by 32. Why does that work? Well, because we remember we said that a division problem can be thought of as a division problem can be thought of as a fraction. Got to make my mouth work today. And in a fraction, I can multiply or divide the top and bottom by the same number. So if I want to get rid of the decimal here, there's only one decimal place, so I multiply by 10. So 3.2 times 10 is 32. I have to multiply the top number by 10 as well, so that becomes 487.39. So moving both of those decimal places is nothing more than just converting fractions. If there were two decimal places here, I would move the decimal point 2 spots, or multiply by 100, yes. So now that it's in this form here, I'm going to divide just like I would my other long division. Does 32 go into 4? No. So I leave it blank above the 4. Does 32 go into 48? Yes. How many times? Once. So the 8 is the last digit I use, so I put the 1 above the 8. 1 times 32 is 32. 8 minus 2 is 6. 4 minus 3 is 1. There's 16 left over. Now what? I bring down the 7. Does 32 go into 167? Yes, it's going to go 5 times. 5 times 2 is 10, carry the 1. 5 times 3 is 15, plus 1 is 16. 32 times 5 is 160. So I subtract, how much is left over? 7. What do I do next? Before the 3 is coming down, before I can bring down the 3, what do I have to do? Move the decimal point up. So now I bring down the 3. 32 goes into 73. Twice. 2 times 32 is 64. That's 9. Now I bring down the 9. 32 goes into 99. 3 times. 3 times 32 is 96. That would be a 3. Well, let's say that my original question here was to find this to the nearest thousandth. Am I to the nearest thousandth here yet? No, I have to go at least another digit to get to the thousandth, right? But I'm out of numbers here. After the decimal point, I can put in zeros. So I bring down that 0. This is 30. Does 32 go into 30? No, it goes in there 0 times. Does that mean I'm done now? I'm at the thousandths? Say no. I have to put one more 0 on there and bring it down. Does 32 go into 300? Yes, it goes in there 9 times. 9 times 32 is 288. 12 left over. I had to go this one extra digit because I need to know whether this one's going to stay as 0 or move up to a 1. Because this digit here is bigger than 5, it's 5 or larger, this becomes 15.231. I have to round it up because that's a 9. If it were 1, 2, 3, or 4, it would stay as 0. 5, 6, 7, 8, 9, it goes up to a 1. So as I mentioned when we were doing whole numbers, I realize you have calculators and you're going to use them. But I also preached have an estimate in your head of what you expect that answer to be before you punch it in the calculator. In this course, I will never force you to do a long multiplication or long division out by hand with fractions. In my math lab, they might have one in there where they ask you to fill in the missing number. They might have it written out like this, and they might have like this number here missing or something. They ask you to fill in the missing number there or something like that. So you do need to know the process. You need to be able to follow along the process enough to figure out what has to go in there. but you don't necessarily have to be able to do the whole process out by yourself. So how do we estimate with this stuff? Well, let's look at addition and subtraction first. If it's a mixed number, why do I call these mixed numbers? Because they have a whole number in front of the decimal point, right? Just like a mixed number for a fraction has a whole number and a fraction, in a decimal, a mixed number, or a mixed decimal it's sometimes called, has a whole number and a decimal. It has a part before the decimal point and after the decimal point. Well, if it's a mixed number like this, the estimation is actually pretty simple, because we just use the whole numbers. This is about 13. This is about 5, right? So 13 minus 5 is 8. I'm expecting an answer close to 8. That's a pretty simple estimation there. So it's when we don't have the mixed decimals or mixed numbers that it's trickier. If I have 0.832 plus 0.094, how would I go about estimating that? Well, yeah, where would I round this off then? What we want to do is we want to look at each number and we want to see what is the name of its first non-zero digit. This is tenths, right? But this is hundredths. So I'm going to probably have to estimate to hundredths. So I'm going to round this to 9 hundredths. This is going to round to 83 hundredths. So now when I add or subtract, I know I keep the same name, correct? So whatever I have here in my result when I estimate this is going to be hundredths, right? What is 83 plus 9? 92. 92 hundredths. Same with subtraction. .738, bless you. 0.738 minus 0.075. It's just more natural for me to look at things vertically like this, so I'm going to rewrite it that way. The first non-zero digit in the top number is in what place value? The tenths. And the bottom number? Hundredths. So I'm going to round everything to the nearest hundredth. So this top number becomes 0.74. The 8 rounds it up. The bottom number will be 0.08. So what is 74 minus 8? 66, yeah. 74 minus 10 would be 64, so you know it's going to be close to that. So 0.66. And realistically, I'd probably do just what you did there, is I'd say, it's about 10, so 60, expecting something close to 0.64. Estimating with the addition and subtraction with decimals is a little more difficult. As you can see here, it's not as, I'm dealing with 2, maybe even 3-digit numbers at times. So the biggest thing I usually keep in mind is, am I expecting something bigger than 1 or smaller than 1? I look at this here. This is smaller than 1 and I'm subtracting from it, so I better get an answer smaller than 1. Does that make sense? Starting with something smaller than 1 and I'm reducing it or subtracting from it, so I better stay smaller than 1. Then my next thing would be, do I expect it to be smaller than a tenth? Do I expect this first digit here after the decimal point to be empty, or do I expect it to have a number in it? Well, this is a 7 and this is a 0, so I expect it to have a number in it. If this were a 1 and this were a 0, well, then it's possible that it might not have a value there. So little things like that. I'm going through this a little quickly because that's what I look at when I look at them. As I mentioned before, estimating, I really detest books that try to teach estimating, because estimating is something that each person sees differently. You look at these and find a way of estimating the answer that works for you. It may be way off from what the real answer is, but it's a way that when you look at it, you get that quick estimate. When you punch it in the calculator, it helps you catch really bad mistakes. Because a problem like this, 0.738 minus 0.075. You can get something like that, 738.925. Is that the right answer?
No,
No, what happened?
you forgot to put the decimal place in the
There's no
first
whole
number.
numbers.
Yeah, when I touched the decimal point for the 0.73, I put in 9 instead of 8 too, which I wasn't trying to do. But when I tried to do the 0.738, I didn't get the decimal point. And on a lot of calculators, the decimal point is a tricky key. On mine here, the decimal point appears as soon as I touch it. But on many of your calculators, the decimal point doesn't appear until you hit the next digit. So you press the decimal point and the screen's still sitting there displaying a 0. The decimal point doesn't come up until you hit the next digit in the tens place. So be careful. There's really not until you finish typing in the number, there's really no way on your calculator to look and to see if the decimal actually registered or not. Some of your calculators, if you hit the decimal point a second time, it cancels it out too. So be careful with that. The TI, that's why I recommend the TIs. The TIs don't do that. There are some, if you double pump the decimal point, it turns it on, then turns it off.
It just keeps giving me decimal points.
It keeps giving you more decimal points if you keep hitting it. Yeah. Okay. Multiplying or dividing. Estimating with those looks a lot like our estimating with zeros. Like if I have 20,000 times 300. When we went to estimate that, we did 2 times 3 is what?
6.
6, and then what did we do?
And a bunch of zeros.
Well, we counted 1, 2, 3, 4, 5, 6 zeros in the problem. 1, 2, 3, 4, 5, 6 zeros in my answer. That was 6 million, right? So when we multiplied with those extra zeros, we combined the zeros. If I have 0.002 times 0.03, 2 times 3, of course, is still 6. But now instead of counting zeros, I count decimal places. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Does that make sense? So when I am multiplying, if I want to estimate, I can do exactly like what we did with our whole numbers. I just round it off to whatever the first non-zero digit is. If I have 0.00193 times 0.0346, I just round this to 0.002 times 0.03, and my estimate is 0.00006. Make sense? For division, of course, division is always, the estimate only works well if it works out evenly, right? But let's say we have 800,000 divided by 400. To estimate, we divided the numbers. What's 8 divided by 4? 2. But remember, we also combine the names. For the zeros, that meant we have 2 zeros here. We cancel out 2 zeros here. So we're left with 3 zeros. So yes, 2,000 is our result, right? For decimals, let's say we have 8 millionths. I says 800 thousandths, I should say, divided by 4 hundredths. Well, 8 divided by 4 is still 2. Remember, when with decimals, it's not zeros, it's decimal places. So I cancel out 2 decimal places, there and there. So I'm left with 1, 2, 3 decimal places. So 1, 2, 3. Does that make sense? So it's the same pattern. It's instead of crossing out zeros, canceling out zeros, we're canceling out decimal places. Up here, instead of combining zeros, we're combining decimal places when we multiply. This is equivalent, by the way. When we multiply exponents with the same base, what do we do to the powers? We added them, right? Here we added, when we multiplied, we added the number of zeros. 4 plus 2 made 6 zeros, right? Here we added the number of decimal places. 5 decimal places plus 2 decimal places made, 3 decimal places plus 2 made 5 decimal places. So that addition being related to multiplication is a pattern. It's not just something that appears with our powers. Same down here. If I had x to the 5th divided by x to the 2nd, now we usually saw it like this, x to the 5th over x to the 2nd. We subtracted. 5 minus 2 is 3, x to the 3rd. Same thing. Here, when we're dividing, we subtracted the zeros. 5 zeros minus 2 zeros left us with 3 zeros. Here we subtracted the decimal places. 5 decimal places minus 2 decimal places left us with 3 decimal places. So that subtraction being related to division is again a common theme. Something for me when I started teaching math and started researching not just the instruction but the origins of math and the history of math. This was not necessarily just this, but in general, it made me very upset that I had actually never been taught math. I had been taught all those shortcuts to make the calculations easier, but I had never been taught the calculations themselves. And this is part of it. One of the reasons why this concept here is so difficult for students to remember, that you subtract powers when you're dividing and add powers when you're multiplying, is that they've never been shown that pattern is consistent throughout different forms of numbers. That you add the number of zeros when you multiply, you add the number of decimal places when you multiply. Or you subtract the number of zeros when you divide, or subtract the number of zeros when you, or the decimal places when you divide. Yeah. Yeah.
It's really pissing me off.
With the power, with the exponents?
Yeah. And multiply, or adding and then subtracting.
Yep.
That's really ticking me off.
Like I said, people, well, why, if we're multiplying, why are we adding? Well, there's a lot of places in math that when you multiply, you end up adding pieces. It's a feature that you're adding. You're not necessarily adding numbers, you're adding one of the features of the numbers. Okay, so now that we know our operations with decimals, it is very possible for us to run into something like this. Might be asked to evaluate for P when D equals 2.5 and M equals 5.1. Well, what that's telling us to do is replace D with 2.5. So it's going to be times 2.5 here. Or I can put it in parentheses. Now I use the X instead of just the dot so that we don't confuse the dot with another decimal point. Minus 5.1. So what do we have to do first here?
Multiply the 3 equals 2.5.
Okay, we're going to multiply 3.8 times 2.5, which is 9.5. Is that correct? Yep. And then we do have to subtract the 5.1. This is 4.4, correct? So P equals 4.4. I probably should have written this out like that. I should have just done this. 9.5 minus 5.1 is 4.4. Or I might ask you to evaluate for D, (1.5 PM over V) when P equals 3.5, M equals 1.6, and V equals 0.8. What am I going to do here? Start replacing. Okay, so what does it look like?
1.5 times 3.5. Yeah, 3.5.
1.5 times, we replace P with 3.5, yep. And then?
And then M will be 1.6 times
So times 1.6, we replace M with the 1.6. And then?
and on the line we have to replace B with 0.8.
So we place 0.8 on bottom, there we go.
Multiply everything out.
Now on top, we multiply everything out.
1.5 times 3.5.
What is that, 8.4? 1.5 times 2.5 times 1.6. I did it all at once. It is 8.4. Good. Divided by 0.8. $10.5.
B equals 10.5.
So D equals 10.5. Any questions? Okay. It's only 11:05. We do have 30 minutes left, 35 minutes left, but I think you guys have had enough for the day. Kind of wanted to slow down a little bit today anyway to give you guys some chance to catch your breath. I know Monday was a rough day. So there is a new quiz. That is due tonight at 11:59 p.m. And there's a new homework that is due on Monday, the 10th. At noon. So I'll let you guys have the last half hour or a little bit more here to get started on anything that you want to, or some of you, I'm guessing, still need to finish up the homework from Monday. I wanted to make sure I gave a little bit more time for that. I will be here. I'll shut off the recording here now, but